Space represents the most uncompromising environments for systems and applications. And consequently, there are major engineering challenges associated with it. The space-grade digital and mixed-signal components developed by Teledyne e2v offer an optimal balance of performance, reliability, and cost-effectiveness.
Welcome everybody to our Grenoble Space Center of Excellence. This is the place where we manufacture digital, radiation-tolerant electronic devices for space. In our space portfolio, we have GHz Class Processing solutions, high-speed memories, high-frequency ADCs and DACs, data converters, and microcontrollers that are all serving dedicated applications in satellites and space systems. In particular, Teledyne e2v Grenoble is famous worldwide for bringing into space compute-intensive solutions that are taking care of multiple amounts of greedy use cases.
Space products are manufactured here in Grenoble according to three key pillars: mastering space components manufacturing and testing, characterization against radiation and mitigation of radiation effects, comprehensive data package and technical support.
As a product engineer, my role is to make sure that all the steps of the space manufacturing flow are carefully followed. Our space offer is based on QMLY and ECSS standards as well as NASA guidelines. All of them apply to a single lot date code. The screening flow consists of a very strict assembly procedure followed by full testing and inspection of each serialized device. Each unit is electrically tested multiple times using original test vectors to ensure that no drifts have appeared during the process. Burn-in is the operation where devices are exercised at extreme conditions. Pre- and post-burn-in allows us to detect early failures and make sure that a lot is compliant with the maximum failure rate. Every single lot is qualified at the end of the space manufacturing flow to ensure the best quality of our components. A comprehensive data package is available for all our customers, including radiation and destructive physical analysis reports.
As project leader for space components, driving product development and radiation testing are a major part of my activity. Since radiation is the key topic when it comes to space, we perform full characterization of our components for both SEE, single event effects, and TID, total ionization dose. For instance, characterization against SEE is a whole and complex project on its own. It includes defining a test plan based on customer requirements, targeted applications, as well as silicon technology. It also requires us to develop and design specific hardware and software for all the tests in order to characterize and monitor CFIs. CFIs are functional interrupts due to radiation effects. Then, we test our components in dedicated radiation facilities across the world, where we put the parts right in front of the beam. And finally, this is the time to analyze all the results before being capable to provide a comprehensive report, which includes cross-sections, latch-up threshold, as well as CFI classification and mitigation recommendations.
At Teledyne e2v Space Excellence Center, we manufacture and qualify parts that comply with space environments and requirements. Our strength and values also lie in the utmost level of customer support we provide.
As an application engineer, my job is to understand the customer's application, understand the challenges they face, help them selecting the best technical solution, and support them in implementing those solutions. A part of my job is to elaborate technical content or material and make that readily available to designers. In this way, they have everything in their hands when they start their development process. That goes from technical documentation such as datasheets or application notes to development kits or any specific material such as signal integrity simulation models required in high-speed designs. Teledyne e2v has a very customer-focused approach. One priority is to create customer intimacy to help design quickly and with the most relevant processing solutions available for the space markets. This brings benefits both to our customers and to our future roadmap decisions.
Thanks to the strong involvement with our customers, a wide variety of our processors is now flying into space for different missions, different orbits, different applications, and today we have processors flying around the world in communication satellites, constellations, and even exploration missions and manned space.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Liftoff.
And soon, our new generation of processing modules will allow us to address AI applications in Earth observation. For more information, please contact us semiconductors.teledyne-e2v.com.